Okay, this is Dr. Morton, and I'm recording the lecture for Wednesday, uh, September 7th, which is Class Day 7, and will be Class Day 7 in future semesters if we reuse this video. So let's look at the syllabus. Let's see, actually I need to turn that on. So here it is, and I think I'm going to blow this up just a little bit so you can see a little bit better. Okay, now we go. Okay, yeah, there we go, maybe even bigger. Okay, and we'll click down here, and we'll shoot down here. So, I did turn, a number of my in-person class folks said that they failed to get the, they didn't realize there were two quizzes due. Number 2 and number 3 due last Saturday, and so some of them didn't get quiz 3 done. So I turned quiz 3 on for everybody. So if you did it and you boloed it and you want a second try, it's there for you. Anybody that didn't get it done, please make sure you get it done by Saturday, and don't forget also the quiz for lecture 4 for chapter 4 is also there, and those quizzes have to be done in the actual textbook. Okay. Then homework, let's see. So homework 3 was due on the 3rd, and then homework, sorry, I didn't say that right. Saturday 3rd, right. Homework 3 was due today, and so I probably won't talk about that because it's late. I know some of you might actually have a chance to see this video. Maybe I'll just take a really quick look at that and talk about that for a second. Hang on. Okay, so here is the homework 3, and yeah, so the truth tables for all the gates should be real straightforward. There were some questions about this question. Draw the following schematic with just 2 layers of NAND gates by using the alternate symbols and sliding the bubbles along the 2 wires. And then see if you can use the same technique and change it into just 2-layer NOR. Okay, so first let me answer the second part of the question first. And the answer is no, you can't turn it into NOR unless you first convert this into a POS form. Right now this has an input layer of AND gates and an output OR gate. That is SOP form. 2 layers, input AND gates, one output OR gate. That's SOP. You're summing up with the OR gate the product terms, the AND terms. So the answer to the second part is no, and that's really all you have to say. The first part, let me just show that really quickly. It's very straightforward. So let me do that. So okay, so over here, what we have then is we have 2 AND gates, and I think this is A and B. Well, I didn't leave very much here. And then I think this also goes B and C, I believe is right. Let's see. Yeah. B and C go into the second AND gate here. And then those both feed into an OR gate. And then that's the output. Now what you do is you replace this OR gate with its equivalent, which is an AND gate with bubbles on the output and the 2 inputs. All right, so if we put that in there, we'll put in an AND gate. I'll just draw it over. Bubble here, and bubbles here, and bubble there. And then what you do is you erase these bubbles and you slide them up. So now you have a bubble here. This looks more like an OR gate, doesn't it? You put a bubble there and a bubble there, and you take them away from here. So now you have the AND gate here and a bubble on its output, and that's then NAND form. So that's real easy to do. It's easier to do on a chalkboard. Let me draw the final thing is going to be the 2 input AND gates, but with bubbles on them now, A, B, and B, C, and then these are going to go into the OR gate. Into the output AND gate, NAND gate, I should say, with no bubbles. So you put the bubbles here, and then you slide them up, so they're gone from here. Okay, does that make sense? I hope. All right, so that's the answer to that one, and it's pretty easy. The graphic technique is really easy. You can also do this using switching algebra. Let me show you that too. That's pretty easy too. Okay, so if we do switching algebra, we're just going to do AB plus BC equals F. And all you do is you just do a double inversion. Put the equal sign over here. And then you partially expand the internal one. And what you do is you put parentheses around these, and you bring this in, and what you get then is you get the quantity AB prime times, because you have to change that operator to an and sign, BC prime, and then the whole thing prime. Now remember, an AND gate is just AB. A NAND gate is AB with a tick. A NOR gate is A plus B. And a NOR gate is A plus B with a tick. So AND, NAND, OR, NOR. And so you can see that's a NAND, that's a NAND, and this whole thing is basically like X, Y, which is also a NAND. So it's a NAND input layer and a NAND output layer, just as we have over here. Okay, so that's it. All right, and I don't think anything else on the homework was really a problem, so I'll leave that alone. Okay, so let me fix this, and then we'll transition. Okay, so I'm going to talk about Chapter 5. We're actually a little ahead of schedule, and then we have plenty of review that we can do. And so what we're going to do, I want to get all the concepts introduced today. And so there's a few things that we didn't cover yet in Chapter 5. I have actually talked about them, but I have not fully covered them. So we're going to do that now. Okay, okay. I also, before I do that, actually, let me go back over here. I'm going to shy away from this, and I'm going to go back to the syllabus for a minute. Let me turn this on. No, didn't want that. What I want is, sorry, that's, here we go. Okay, and boom. And then we'll transition. Okay, so what we have here, so this is the schedule. Keep an eye on this. And then if we go down to, so here we are on week 3, Wednesday, September the 7th. So we're still going to do some work on converting from POS to SOP and from SOP to POS. We did some of that on last Friday, and then but we're going to go ahead and move on. We're going to hit Chapter 2 on Friday anyway. I just want to get a little bit of a leg up on that, and then we'll go back and we'll work some more on the SOP to POS stuff. Today, though, I want to cover the min and max terms in the shorthand notation. All right. That having been said, let's go back to the the book. So if we scroll down, so these are again the learning objectives for this chapter, and a lot of this chapter is overviewed and covered in this video, which you should definitely watch. Probably what you ought to do is watch this for Friday, and then I may do a supplementary video for Friday as well. Okay, so here's what I want to talk about. So first off, this is a 3-variable truth table. We have variables A, B, C, and so that's 3 variables. So our n for the number of independent variables is 3, A, B, and C. So 2 to the n rows are what we have to have, 8 rows. Okay, and every row has a min term defined, and every row has a max term defined. Now, when you actually write the min term or max term expression, you never include all the min terms, and you would never include all the max terms. That would be crazy. What you do instead is you pick the min terms for rows where the desired output is a 1, and that gives you a solution in min term form. Or if you want to do the max terms, you pick the max terms for the rows where the desired output is a 0, and then you AND those together. That gives you the the max term expression, and you OR these terms together, and that gives you the min term expression. And then normally you have to simplify it because they're normally not in the simplest form. Okay, so let's see some examples. So here's an example right here. So this f is, well, let me back up. I want you to be able to look at a truth table, say a 3-variable truth table in this case, and be able to write the min term for any particular row or the max term for any particular row. Now, it turns out that for any particular row, the min term and the max term are exact inverses of each other, which basically means when you OR the min terms together, each min term will generate a 1 for that row. And if you AND the max terms together, each max term will actually generate a 0 for that row. So that's why when you want to write the solution, you only pick the min terms and the max terms. You pick the min terms for the rows where the desired output is 1, and that gives you one solution. Or you can pick the max terms for the rows where the output is 0. And so the max terms will give a 1 for any row where the desired output was a 1, and it'll give a 0 for any row where the desired output is a 0 if you only select and AND together the max terms for the rows where the desired output is 0. Let me show you how it works. And likewise the min terms. If you only OR together the min terms from rows where the desired output is 1, each min term will contribute a 1 for that particular row, and that's how you get the solution. And again, the min term solution and the max term solution are exactly equal. And you would never pick a min term and a max term from the same row because the output is either 1 or 0. If it's 1, you'd pick the min term if you're doing a min term solution, and if it's 0, you'd pick the max term. But since it can never be both, any particular row, for whatever particular solution you're going for, you're only going to have those min terms or those max terms. All right, never the same for different solutions from the same row. All right, so let's say here's an example. So I think I'll shift to the paper and we'll write this. But I'm going to use this example for f. F is 1, 1, 0, 0, 1, 0, 0, 0. So that's the desired value for f. Now I know it always is the case that people get confused and they go, well, how did you know what those values for f were supposed to be? Okay, relax. You don't have to figure that out. At least indirectly you do, but directly you don't, because your customer gives you that. Now they may give it to you in English and you have to take it from English and put it in a truth table, but they're going to tell you what the desired value is for each combination of the input of the independent variables, the ABC in this case. You could have more variables, you could have 2 variables or whatever, but in this particular case we have 3 independent variables, 1 dependent variable, and this is what the customer wants for that dependent variable for each of these combinations. And these are all the possible combinations for ABC. Okay, that's what the truth table is. That's what it's all about. Now you should be able to take this truth table and immediately write down the min term and the max term expressions. Now we have 2 forms of those. We have the shorthand notation and we have the actual expression. So we have the min term shorthand notation and we have the max term shorthand notation. We have the min term expression and the max term expression. So let me use this truth table and show you those 2 different expressions. So first I'm going to copy to my paper this truth table, and then we'll work on it. Okay, so here it is. So it's going to be, maybe I'll let you might as well see that. So let me, okay. So we have A, B, C in our output F. And then 1, 2, 3, 4, 1, 2, 3, 4. So we have 8 rows. A is our hard order variable, so it only changes once as we go down the rows. The B changes a few times. And the C changes with every row. And this gives us 8 unique combinations, which include all the possible combinations for our 3-variable problem. All right, and I'm going to draw some lines here. I hope I can draw them in neat enough that it doesn't obscure everything. All right, now remember, we have defined a minterm for every row. So let's go back. Let's see. Let's go back here and we'll scroll up here. So these are the minterms for every row. So which rows do we need? Well, so we're going to go back. We're going to go back down here, and I'm going to use the drawing again. So our this particular example, f is 1, 1, 0, 0, 1, 0, 0, 0. And again, where did we get that from? This came from God. Okay, that's one way to think of it. Or your customer. All right, now, so that means we're going to need 1, 2, 3 minterms. And if we write the maximum expression, we're going to need 1, 2, 3, 4, 5 max terms, because there's 5 rows where 0 is desired as the output and 3 rows where 1 is. All right, so let me first write the shorthand notation for the minterms. So for the minterms, we say f equals the sum of the minterms, the little m's, and then we put down the number for each row where we need that minterm. Well, so I label the rows 0, 1, 2, 3, 4, 5, 6, and 7. So what are our rows? Well, 0, 1, 4. 0, 1, 4. So that is how we write the minterm expression. And the maximum expression is very similar. We would just write this also equals the max term expression, which is the sum or the multiplication of the capital M's, which are the max terms, because we're going to AND those together. Here we're going to OR them, so sum them. Here we're going to AND them, so multiply them. And we use the little pi sign for multiplication. And now we want the rows where we have zeros. Here, so that's 2, 3, 5, 6, 7. 2, 3, 5, 6, 7. Now, when you look at this, you don't see the actual logic expressions. This is the shorthand notation. And if I ask you to give me the shorthand notation, that's what I want. But if I ask you to give me the expression, now I want you to actually write out the minterms. And then usually we have to simplify them. But for this exercise, I'm just going to write them out. So what are the 3 minterms? Well, if we go back to our document, then what we can see if we pop this up is that we have a defined minterm for every row. Now, at first you look at this and you think, wow, this is confusing. Not really. So notice here, A is 0, B is 0, C is 0. So the minterm is A prime, B prime, C prime. Here we have A is 0, B is 0, but C is 1. So we have A prime, B prime, C. Here we have, say, 0, 1, 1 for this row, which is row 0, 1, 2, 3. And we have A prime, B, C. And here we have A, B, C, because they're all ones. So it depends on whether our input variables are ones or zeros. That's how we write these minterms. Now, if we take this minterm and just invert it, it exactly gives us the max term. So the max term, obviously, if you invert A prime, B prime, C prime, you get A plus B plus C. So this would be an OR gate, this would be an AND gate. Here you get A plus B plus C prime, because C is not primed. And so we have to flip all the variables and add in and change the operators. So we change the ANDs to ORs, and we change the primes to non-primes and the non-primes to primes. We do that for every row, and down here ABC becomes A prime plus B prime plus C prime. So you should be able to write the min or the max term for any of our particular rows. And remember, we number these 0, 1, 2, 3, 4, 5, 6, 7. Okay. Okay, back to our problem then. So now that we know how to create the minterm for each row, so let's write the minterm, not the shorthand notation, that would be this. And this would, again, this is in SOP form, and the minterms. This is max terms, and this is POS. Okay, so we're gonna write the minterm expression now, which is going to be in SOP form. And so that would be F equals, so we need 0, 1, and 4. So minterm 0 is going to be A prime, B prime, C prime, plus 1, A prime, B prime, C. C because the C's a 1, and A and B are zeros. and then 4. That's going to be A, B prime, C prime. Now notice, so we have this row, min term 4, because that's a 1. We have a 1 here and a 1 there. So we use 0, 1, and 4. We didn't take row 2, 3, 5, 6, or 7 because the desired output for F there would be a 0. And if we put in the min term, we would be changing that to a 1 instead, because this will give us a 1. Now, first off, many students look at this, and how can that do that? Well, let's just convince you, yes, this really works. So pick a row, any row. Okay, you want to pick row 6, where we have, so pick row 6. So the value in row 6 is A equals 1, B equals 1, and C equals 0. Let's plug that in. It should give us 0, but does it? Well, okay, so A is 1, B is 1, C is 0. So if in any of these terms, if any of these terms turn out to be a 1, that's not going to be a 0. So all these terms have to turn out to be 0 for this to actually give us the right answer. All right? So here we have A prime. A is 1, so A prime would be 0. So that's immediately 0. And then here we have A is 1, A prime, that's a 0, so that term is also going to be 0. We didn't even have to look at the B and the C. And here we have A, B prime, C prime. So A is a 1, but B is B prime, so if B is 1, B prime is 0, so now that term's a 0. So 0 plus ORed with 0, ORed with 0 is 0. So now, yes, it does give the correct value. Okay, and again, that was row what? That was row 6. Now let's do row 4, where the correct answer is a 1. All right? So that's going to be A equals 1, B equals 0, and C equals 0. It's a different row. We have a different combination of our variables. And here we go. All right? Let's put A in here. Well, A is 1. A prime would be 0, so that's going to be 0. So that's, forget that. Then how about A prime? Same thing. A is 1. A prime is 0. So that's going to be 0. How about here? A is 1. B is 0, so B prime would be 1. And C is 0, so C prime would be 1. So that's 1 ended with 1 ended with 1 equals 1. And 0 ORed with 0 ORed with 1 is 1. So it does give the right answer for that row. And it turns out that for row 0, it would also give the right answer because A, B, C are all 0, so this term would become 1. For row 2, this term would become 1. And then finally for row 4, we just saw this term becomes 1. So these make it 1 for these 3 rows and 0 everywhere else. Exactly what we want. What about the max term? Same thing, only the opposite. So we have F equals 2, 3, 5, 6, 7. So we're going to have to write a little bit here. So the max terms, a little bit harder. I have to think about them a little bit. But so F equals, so the second max term, we can go back and look. But I happen to know it's A plus B prime. So A plus B prime plus C. Max term 3 is going to be A plus B prime plus C prime. Max term 5 is going to be A prime plus B plus C prime. Max term 6 is going to be A prime, B plus B prime plus C. And max term 7 is going to be A plus B plus C primes. Okay? So that gives us 1, 2, 3, 4, 5 terms. Each one of those terms is only going to be 0 when we have the right combination of variables for that row that needs to be 0. And it'll be 1 everywhere else because one of these variables will be a 1. So all of them have to be 1s for it to be a 1. And that generally will be the case. Let's do an example. Okay, so let's take a row where we want it to be a 1. So that would be row 4. Okay, so for row 4, we have A equals 1, B equals 0, C equals 0. All right, so A is 1, so that's going to be a 1. A is 1, that'll be a 1. A prime is 0, so B, but C is 0, C prime then would be a 1, so that'll be a 1. Because remember, these are all ORed together, so if any one's a 1, it becomes a 1. And then here we have A prime, B prime plus C. So A is a 1, that doesn't help us. B is a 0. B is a 0, so now B prime would be a 1. So that is a 1. And then here we have A prime, B prime, C prime. And B is a 0, so that would be a 1. C is a 0, so that would be a 1. So this is a 1. So now we have 1 times 1 times 1 times 1 times 1. F equals a 1. And that's what we desired for row 4. Remember, row 4, F is supposed to be equal to 1, right here. So that's correct. So now we know that it works. And it'll work for any row we pick where F is supposed to be 1. If we pick a row where F is supposed to be 0, what happens is one of these terms will go to 0. Let's pick the first row, 0. So for that row, A equals 0, B equals 0, and C equals 0. So that means A prime equals 1, B prime equals 1, and C prime equals 1. All right? So so here we have, let's see, did I do that? 1, 2, 3, 4, 5. Oh, yeah. Sorry, I don't know what I'm saying. This is row, this should be a 1. I screwed that up. Let's pick a row where the desired output's 0. That would be row 2. Okay, row 2, and also 3, and also 5, 6, and 7. Well, let's do 7. What the heck? So for 7, A equals 1, B equals 1, C equals 1. All right, so all we have to do is find any of these variables that aren't primed, and we know that that's going to be 1. So C is not primed, so that'll be a 1. Or is it? Yeah, it's not. Right. And A's not primed, so that'd be a 1. A's not primed, so that'd be a 1. B's not primed, so that'd be a 1. C's not primed, so that'd be 1. But look at this. All 3 of those are primed, so this is going to turn out to be a 0. 0 times 1 times 1 times 1 times 1 is 0. So for row 7, F equals 0. So it works. So our max term expression and max term and min term expressions do in fact always give us the correct answer that we desired for our output F. And that's why that's how it works. We pick the min terms from the 1 rows, and that gives us one solution. We pick the max terms from the 0 rows, and that gives us another solution. And those solutions always exactly equal each other. They're not the inverse, even though the terms are opposite. The terms from row 0, the max term and the min term, are inverses. But we would never have both those in a single solution because they would contradict each other or whatever. All right. Okay, so that's that. So I wanted you to see that. I wanted to go over that. And that's probably the big thing I wanted to talk about today. So let's see. So we're about 27 minutes. I may keep this short and just go ahead and end it here. Let's see. Was there anything else I wanted to cover? Let me. I'll scroll down. Let's see. So we're going to talk about English to Boolean. Probably talk about that some more on Friday. And yeah. So okay. So what form is this diagram in? As you look at that. Oh, sorry, you can't see it. What form is this diagram in? As you look at that, what do we have here? Well, it's a funny depiction of an OR gate, but these are supposed to be OR gates because it's got the curved input instead of the straight line. So we have OR gates in the input, and these look like OR terms, but we're ORing them together, so there's pluses in here. And each of these OR gates feeds into this one AND gate. So that is we are multiplying together the results of these OR terms, or so it's a product of some terms, if you will. So it's POS. That's the POS, or this is the max term solution. And of course, we should be able to simplify. All right, one more thing I did want to mention, this incompletely specified function. I'm going to talk more about this. Sometimes we have a situation, let me go down here. Oh, I think I put that on there. Yeah, okay. Sometimes we have a situation where we have a truth table, and our customer tells us that one of these combinations of our input variables, or maybe more, but one, say for sure, is never going to occur. So in this particular case, we write an X there. Now I've mentioned this before, but I just want to hit it again. So notice for the row 0, if A is 0, B is 0, C is 0, our customer wants F to be 0. If A is 0, B is 0, and C is 1, our customer wants F to be 1. If A is 0, B is 1, and C is 0, our customer wants F to be 0. And so forth. For each row, our customer is as laid out what they want. Now usually they just described how they wanted this thing to work, and we have to figure out what outputs are required to make that happen. So that's kind of our job. But guess what? We got down here to this row. A is 1, B is 0, C is 1, and our customer says, oh, guess what? That's never going to happen. For whatever these A, B, and C represent signal-wise, you're never going to have this combination. A is 1, B is 0, C is 1. So I put an X there. And what that allows me to do then, as the engineer designer for this network that's going to implement this truth table, be it a SOP or POS or maybe NAND or NOR, however I'm going to do it, I can pick whatever I want F to be for that row, because our customer says that combination of inputs will never happen, so it doesn't matter what output F is, because it'll never happen. And we call that a don't care. So it isn't that we don't care, we actually do care. We want to choose it carefully to allow us to get a simpler solution. And most of the time, it makes a big difference how we choose it, and it will give us a simpler solution in most cases. Not all, but many cases. Maybe almost all cases. Let me say that. All right. So that's our don't care. And we call that an incompletely specified table, because that particular row right here, we did not specify a desired output for F. We said, well, you can make that whatever you want, because it's never going to happen. So we don't care. Okay. All right. I think with that, we'll stop here. And so I want you to watch. So hopefully you've just finished watching this video, and be sure it might help you. You've got another hour yet to turn in your homework if you want to work on this, and I'll send out a little notification. All right. With that, we'll quit.